Welcome back to Unraveling Mechanics, where we explore the fascinating inner workings of everyday technologies. Today, let's uncover the secrets behind refrigeration and air conditioning technologies that keep us comfortable and our food fresh. Refrigeration Mechanics. Refrigeration is a process that involves cooling a space or substance below its ambient temperature. Its primary goal is to preserve perishable items by slowing down bacterial growth. You've encountered this technology in your refrigerator and freezer, where it keeps your food fresh for extended periods. Mechanism and working principles. At the heart of refrigeration is the concept of heat transfer. The system relies on a fluid called the refrigerant that changes states between liquid and gas to absorb and release heat. Here's how it works. Compression. This process begins with the refrigerant in a low-pressure gaseous state. A compressor increases the pressure, causing the refrigerant to heat up. Condensation. The hot high-pressure gas enters the condenser coil, releasing heat into the surrounding air. This causes the refrigerant to transition into a high-pressure liquid. Expansion. The high-pressure liquid refrigerant passes through an expansion valve, causing it to rapidly expand. This leads to a drop in pressure and temperature. Evaporation. The low-pressure, low-temperature refrigerant liquid-gas mixture enters the evaporator coil. As warm air from the surroundings passes over the evaporator coil, the refrigerant absorbs heat, evaporates into a low-pressure gas, and cools the surrounding air. This cycle of compression, condensation, expansion, and evaporation continues, leading to a continuous cooling effect. Think about your refrigerator at home. Inside, the refrigeration system continuously removes heat from the air, allowing the temperature inside the fridge to drop. As the air cools, moisture in the air condenses, creating a controlled environment that extends the shelf life of your groceries. Air conditioning mechanics. Air conditioning is a technology that not only cools the air, but also controls humidity, creating a comfortable indoor environment. It's a savior during hot summer days, providing relief from the heat and creating a more pleasant living or working space. Mechanism and working principles. Air conditioning operates on similar principles to refrigeration, but it involves cooling the air in a larger space rather than a confined area. Here's how it works. Air circulation. Air from the room is drawn into the air conditioning unit. Cooling process. The air encounters the evaporator coil, where the low-pressure refrigerant absorbs heat from the warm air. As the refrigerant evaporates, it cools the air. Compressor and condenser. The cooled air is now directed back into the room, while the hot refrigerant gas moves to the compressor and condenser units located outside. Here, the heat absorbed from the indoor air is released outside. Refrigerant cycle. The refrigerant cycle continues, with the refrigerant transitioning between states and absorbing and releasing heat. This process keeps the indoor air cool and comfortable. Types of refrigeration and air conditioning. There are several types of refrigeration and air conditioning systems, each designed for specific applications. Some common types include vapor compression system. Found in most household refrigerators and air conditioners, it utilizes the principles we just discussed. Absorption refrigeration. Often used in large industrial settings, it uses heat as the energy source to drive the refrigeration process. Evaporative cooling. This method uses the evaporation of water to cool air, common in swamp coolers. Air conditioning systems work by drawing in hot air from the surroundings, passing it through a cooling process involving the refrigerant cycle we talked about earlier. The cooled air is then circulated back into the living space, providing a refreshing oasis even in the hottest of climates. With a deeper understanding of refrigeration and air conditioning, you now grasp how these technologies enrich our lives. From keeping our food fresh to making indoor spaces bearable, the principles of heat transfer shape our modern world. Thank you for joining us on this episode of Unraveling Mechanics. If this exploration into the mechanics behind refrigeration and air conditioning has piqued your curiosity, don't forget to give us a thumbs up and subscribe for more captivating insights into the mechanics that shape our world. Stay curious and stay cool.